So that also shows any sample if you take, many of the sample mean are around 300. So population mean 300, sample mean can be less than 300, greater than 300. So there is always a level of significance to decide about the decision. There is always a level of significance to decide about the decision whether we accept H0 or accept H1. And since the level of significance is 0.05, H1 is two-sided, 0.025 to the left and 0.025 to the right. That is what I have shown on the graph. So how many percent value below yellow line? What is the percentage of sample below yellow line?
So 25%.
How much?
So 25, no sir, 20, so 0.25 sir. Like,
correct. How much will be above the green line?
2.5.
425.
Correct. So between the yellow and the green line, how much?
95%.
That is called acceptance area. Others are called rejection area. Now, your sample 295 is which side? Or where is your sample?
it is acceptance side, sir.
Yes. So what is the conclusion?
Accept H0.
Accept H0. But this you cannot do all the time in the question. Therefore, there is a standard procedure using standard normal distribution. Using standard normal distribution. And standard normal distribution is always symmetric at 0, whichever may be the data. Whichever data you take. Standard normal distribution is always symmetric. At 0. So, for the given level of significance, you find the cutoff value using standard normal distribution. Left will be 0.025, right will be 0.025. Finished. And your sample will give you Z, that is minus 1.76. Formula is there in your question paper of module 5. So minus 1.76 is in which area?
It's a rejection region.
Minus 1.76 is in which area? Check your graph. Check the critical value.
Yeah.
Acceptance region.
Acceptance region.
That is between minus 1.95 to plus 1.95. So accept H0. So standard normal test Z, that is enough to make the testing of hypothesis of mu. In the next question was IQ. But it is greater than or equal to or less than. So it is a one-sided hypothesis. So R always shows a T instead of Z. So we have to use the notation T. Compute it. What is the conclusion?
Accept H0.
Accept H dot because lower critical value is minus 1.55 and your T value will be in the acceptance region. So accept H naught. This is data given. Critical value approach. But directly if the data available, then how to do? That was the next work I have shown. Probability procedure, p-value procedure. P-value. I took the data from sleep. People are having sleeping time above normal time, or people are having the sleeping time below normal time. Compute everything and repeat what I have shown. Finished. In critical value method, you want everything to be computed, mean, standard deviation, n, etc. But in p-value method, we don't want to do that. It has only one syntax, t-test. T-test. Say 1% level of significance is given. So confidence level is 99%. See the syntax. Test X represents sleeping time. Mu represents hypothesis value 1.5. Confidence level is 1 minus alpha. Suppose if I take 1%, my confidence level will be 0.99. P value 0.9303 greater than. Come on. What is the conclusion?
Accept
Accept
H0.
not. Similarly, I have shown the data with car. speed and the distance traveled by the car. H0 I am talking on speed, 20. Apply t-test again. T-test as mu equal to 20. Very, very small p probability. That is less than the level of significance any you take. 1%, 5%, 6%. So what is the conclusion?
Reject H0.
Reject H0. This is p-value approach. Then I went for 2-parameter test. Critical value approach. Exactly like what we did in critical value approach. Only T formula will change because 2 samples. Both examples we have done by critical value approach. But if you want to apply t-test by R, take the data again, sleep data. Extra sleeping time between 2 groups. Group is nothing but say male and females. Ten males are there and 10 females are there. Compare the average sleeping time. There the syntax will be only one with. With stand for data file. With the file sleep, t-test x, x stand for sleeping time and y stand for group. Give the confidence level 0.99, 0.95, whichever in the question. Whichever in the question. So, see p-value. The p-value is 0.073939 and level of significance 0.01. So what is the conclusion?
Accept H0.
Finished. So 1-parameter test and 2-parameter test, critical value approach and p-value approach are shown to you. But in the remaining topics in your statistics, we always have p-value approach, keep in the mind. Whether it is ANOVA, whether it is chi-square, just like V.V. Giri asked today morning, correlation regression, whichever, every approach will be by p-value approach. The remaining module 6, 7 are generalization of whatever we have done. For example, ANOVA technique. ANOVA technique. The full form of ANOVA is analysis of variance. Analysis of variance. Let me explain you. The time required by 3 workers to perform an assembly task were recorded on 5 randomly selected occasions. Workers are Hank, Joseph, and Susan. Independent data. The hypothesis is H naught. Average assembly time of Hank, mu h. Average assembly time of Joseph, mu j. Average assembly time of Susan, mu s. They are equal or not all are equal. H1 I cannot specify. H0 I cannot specify. Because if H0 is true, meaning is minimum one of the parameter will be different from others. So H1 will be at least one of them differ from others. Critical value approach is very difficult. And since you are learning R package, you have to practice R. Very simple. So testing of hypothesis on more than 2 parameters is called ANOVA technique. More than 2 parameters. ANOVA technique is a statistical procedure helps to compare more than 2 parameters, independent parameters. But variable is one. Assembly time. Each data is 5. 5, 5. So to test the hypothesis of H0, ANOVA technique has following algorithm. Type the data first. Small data. If the data is huge, then we can go for reading. I will show you that, how to read the data from the file. So let us see typing. Workers. Hank 5 times. Joseph 5 times. Susan 5 times. String data. Already we have seen in table. Very long back. Accordingly, their data time. Hank 5 observations. Joseph 5 observations. Susan 5 observations. Only one syntax you do. What is the syntax? Model assign AOV function. AOV function means ANOVA. Workers. Not workers versus time. Variable is time. Workers is group. And summary of the model. In our R, let us go to the new file. Dealing with module 6 and 7. So first we are doing ANOVA. Only one syntax. Workers, Hank, Joseph, Susan. Corresponding data. AOV function. And obviously your hypothesis will be all of them are equal. All the parameters are equal. This is hypothesis. Run it. Finished. So instead of looking these degrees of freedom, sum of square, mean square, f value, etc., directly you look the p value. P value means probability value, 0.251. So the conclusion here will be, since p value equal to 0.251, much greater than level of significance equal to 0.05. accept H naught. Finished. The decision rule never change. So ANOVA technique is concluded with p-value approach.
So,
Yes.
before moving with this ANOVA, could you please give us a brief of ANOVA, like why and where do we use it exactly in statistics?
Yeah. Yeah.
Thank you, sir.
Yeah. In our module 5, we have done testing of hypothesis up to 2 parameters. But parameters need not be up to 2, it can be any number. So wherever the parameters are more than 2, ANOVA technique will be used. That is what the example. What is the example here? Assembly time by 3 workers. Hank, Joseph, Susan. So the hypothesis will be mu h is equal to mu j is equal to mu s. That is, average assembly time of all the 3 sources are same. How to perform it? That is what the algorithm on the screen. Type the 3 workers. Hank 5 times because 5 observations. Joseph 5 times 5 observations. Susan 5 times 5 observations. Time data are the typing work because here the data is small. If the data is large, we can read directly from the file and work. We can read the data from the file and work. And only criteria is this syntax. Model is ANOVA AOV time versus workers. Summary. Finished. Only 2 syntax. That is what the output you can get on the screen. That is the output you get on the screen. You look at the last probability value and the probability value will be 0.251. Compare with your level of significance, conclude thus. This is called one-way ANOVA technique. Because only workers. Let us look at the next question.
Sir, is it the only syntax or are we using shortcut?
Only syntax. Only syntax.
Okay.
Model is assigned by AOV time versus workers. Let us see the next share question in the question paper. Same workers. Same. But the data collected from different shift S1, S2, S3, S4. S1, S2, S3, S4, S5. So the data is coming from 5 different shifts. Not necessarily equal. Suppose Hank is for 5 shift. Joseph may be for 6 shift. Susan may be for 9 shift. Then one-way ANOVA we can do. But in two-way ANOVA, the data will be equal, row-wise and column-wise. So there is 2 hypotheses. One, comparison of workers. 2, comparison among shift average. So one more time you have to type the data shift. Do AOV function one by one, time with worker and time with shift. That is what I'm showing you. One hypothesis is for workers and the second hypothesis is for shift. So 2 times I have to do ANOVA. This is called two-way ANOVA technique. Comparison among the rows and comparison among the columns. So let me share with you my R. I am dealing with now two-way ANOVA. Hypothesis 1. Workers wise average is equal. Hypothesis 2. shift averages are equal. Data same. So, one way ANOVA. Repeat it. See, answer as you got earlier. See the answers that you are getting. Suppose shift wise I have to do. Then again I can repeat the same work. I denote it model 2. Time versus shifts. Summary, model 2. See? See? Hypothesis different. P values also different. But if we consider at a time, then the syntax will be model 3. Time with workers and shift. That's all. P value will change, but conclusion almost the same. So in the algorithms, only unique algorithm A or B. A or B. Because data is small, we have typed.
Sir, why the p value has changed here?
Yeah, because x plus 3 equal to 10. How much is x?
The 7.
7. X plus y equal to 10. Then how much is x and y?
Sir, it depends upon y.
Correct. Or it depends on x, correct? Huh? Both the ways.
Yes, sir.
Same algebra.
Sir, just a doubt.
Yes.
What is the difference between model 2 and model 3? What exactly is model 3 telling us?
Together. Test the hypothesis in one performance, one table. Instead of one after another, at a time, do ANOVA technique. Clear?
Sir, not really, sir. I'm not
Time.
really understanding what.
Time.
I'm not
Time is,
understanding what is.
assembly time is associated with worker and their shift.
Yes, sir.
So you are performing at a time the test of hypothesis of shift and workers. Now it's clear?
No, sir, not
Sir,
very
but in
clear.
model,
Yes, yes. Suppose if I don't give the shift, like first question. So the data is coming from the workers, isn't it? Yes.
Sir, from what I've understood, model 1 tells us if the mean of the different people are similar or same or not, that is our H
Yes.
naught.
Yes.
In model 2, we try to find out if the mean over the different shifts are same or not.
Yes.
And what is, I can't understand what model 3 is still telling us.
Yes. 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 So here independently I worked it now. Model 1 and model 2, I repeated the test of hypothesis, correct now?
Yes, sir.
But the data is related to both workers as well as shift, correct now?
Yes, sir, both is related to both.
So the hypothesis will be comparison among workers as well as comparison among shift.
But sir, now that we're running the test together, the F value and the values are changing, the last two columns.
Obviously, because when you are comparing with worker, you are ignoring shift. When you are
Oh,
comparing
okay,
with
okay.
shift, you are
Okay.
ignoring workers.
Okay, sir.
Very good. It's clear now?
Not 100%, but quite a lot more.
That is what I told the algebra. Suppose if you have an equation x plus 3 equal to 10. So x has a unique value. 7. Correct na? Is it correct?
yes, sir.
If x plus y equal to 10, then what are the possible value of x?
It depends on both x and y, sir.
But in both these equations, the right hand side is 10.
Yes, sir, it is given.
Same way, comparison of means. That is what you are doing in ANOVA technique.
And sir, how do we interpret this one? Last.
Right hand side of the equation is same. But the value of x in one case unique, but in the second case value of x depend on another variable y. So when you consider shift and the worker, how the shift accordingly the working time, or how the workers will be the according to the shift they work. So you want to know whether workers and shift has interaction with respect to averages. Is it clear? That is two-way ANOVA.
Sir,
Yes.
sir, how do we interpret this last model 3 wala result and with reference to the hypothesis?
Yeah. Suppose if I want to do the hypothesis only one, then I can apply one-way ANOVA. Okay. Is that clear?
Yes, sir.
But if I have to compute both hypotheses same time, then two-way ANOVA. Comparison of average among the columns and comparison of average among the rows. That is two-way ANOVA.
Sir, so we have to check again the p-value for the conclusion of two-way ANOVA, right?
Correct. The concept of p-value is enough every time from today onwards.
So, for two-way ANOVA, how will we write the conclusion for it?
Yes, accept H naught both. Workers as well as shift. Because p-value is 0.296 for workers and 0.587 for shift.
Sir,
Yes.
what we did with these two models was, in the first we did within groups mean square, and the second next was between groups mean square.
Both the case.
Yeah.
One way otherwise between the groups, and the last model will be interaction between two groups.
Yeah.
Effect of data from source 1 and source 2. That is model two-way ANOVA. And now it's clear. Can't you see? Shift-wise the data changes for Hank. Can't you see? The data for Joseph also changes from the shift to shift. On the same shift, is it they are having the same values? Tell me. No. So in two-way ANOVA, you are dealing with interactive mode. Two-way ANOVA technique. So here I am typing the data. But as I told you, typing is very difficult.
So in a two-way ANOVA, what if the p-value is different for workers and for shifts, and for one
So
it
one of them will
is...
be accept, the other will be reject or possible.
So then, sir, what implication will this have on the time?
There is a significant change among the workers and there is no significant change in the product in shift. Average mean.
Okay, sir.
Sir, in which model we have done comparison among rows and in which we have done comparison among columns?
Yeah. Yes. That is what the question, one-way ANOVA, two-way ANOVA. But how to do this direct data reading from file algorithms? Sleep data, car data we cannot do because there is no other variables. But let us see if data chick weights. Let us see what it is. Just like the sleep data and car data, there is another file called chick weight. So like every other problem we have done, first read the data from file. Read the data from the file. So the name of the file here it will be chick weight. So this file has two variables, weight of the chicken and the type of food they eat. So W denote weight, F denote the food. How many chicken in the data? How many? What is the sample size?
72, sir.
71.
71. How many type of food in the sample? 1. Horse bean. 2. Linseed. 3. Soybean. 4. Sunflower. 5. Wheat meal. And 6. Casein. Correct, na?
Yes, sir.
So how
Sir,
many
how can we-
parameters for the weight?
6.
6.
Sir, how can we directly check the levels? Like if there are a lot of levels in the data set, then how can we check that?
See the 71 number last. Or already I have shown to you. Type the length. Length of W. How many?
Sir, this will give number of observations. I'm asking about
what I
levels.
said.
No, levels. Like if 71 observations are classified in 6
So
levels.
type of food are counting.
Sir, in this situation, we have 6 different types, right? If like there are
X
100
is not different.
type of food, sir, type
Group
of
is
food.
different.
This I'm talking about F only, sir. Horse bean.
Horse bean one group.
Yes, sir. Sir, if there are a lot of groups, how do we check how many groups are there and what are they?
It will list on here na.
So we basically scroll down. Like, can we not get levels directly? Like level saying it horse bean, comma, soya
Try
bean,
करके
comma.
देखो. Try करके देखो.
Okay, sir.
So how many parameters we have here? Anybody?
6.
6 parameters. Six parameters you have. mu1, mu2, mu3, mu4, mu5 equal to mu6. So you have now the hypothesis. Model 1, weight with food, finished. Typing time reduced. What is the conclusion now? What is the p-value?
Sir, it is
How
less
much?
than level of significance.
Yes, sir.
By default, any level of significance you take, it shows on the screen. How much is the p-value?
P value is next to 0.
Yes, that is what we say. Equal to 0. Approximately equal to 0. Which is much smaller than any level of significance. So, conclusion is reject H naught. Finished. Reject H naught is the conclusion. So the working, there is no difference. Typing time reduced. So whenever you open a file, check the nature of that content in the file. Frame a hypothesis. Do. Same way, one more data we can show. A very huge data. For Slater point of view, wool is necessary. There are different type of wool and there are different type of breaking strength. So you want to know what is it? So let us see the data. Data is, name in the file is warp break. What are they? Yes, 3 variables are there: breaking strength, type of wool and tension. You want to know the data. So I have the variable breaking strength is BRX. You can give any you like. Wool, type of wool, and tensile strength is tension. Say you want to know BRX, you want to know what is in wool, you want to know what is in tens. Can anyone tell me what is the nature of the data?
The characters.
The characters of wool, tensile strength, and
yes. How many type of wool?
2 types of wool, sir.
How many type of tension? Tension means pull the wool, it will break.
3, sir. Low, medium, and high.
Correct. And the data is actual breaking strength, isn't it?
Yes, sir.
So each breaking strength is depending on the type of the wool and the tension of the wool. Just like 3 workers, assembly time, along with the shift.
So can you please repeat this part?
Yeah. The data consists of 54 samples, which include two types of wool and the level of pressure. Breaking strength के लिए little pressure, medium pressure or high pressure. So each observation is associated with the type of the wool and what measure will be used for the tension. So how many hypotheses? Come on. One for
Type of wool,
second for
tension,
finished. The hypothesis H01, that is for brakes. H02, that is for level. H01 is for wool.
So, can you just wait 1 minute while we write down the code?
Yeah, write down.
Sir, what is level?
Levels are low level,
Tension level, sir. Okay.
medium level, higher level.
So
Shall I
could you please
continue?
scroll up the results? One.
Yeah.
Yes, sir, you can continue.
Yeah. Now see the output ready within no time. First is for wool. What is the conclusion?
Fail to
Accept or
reject H
reject?
naught. Fail to accept H naught.
Accept it. For the level,
Reject H naught.
correct. See both the answers on the summary together. Come on, see the conclusion.
Sir, we accept for wool and we reject for tension.
Finished. So in check weight data, we have shown In warp break data also I have shown to you. Algorithm never change. Either you are typing the data or reading the data. Either you are typing the data or reading the data. That is the only difference. Let us see the yes.
Sir, will you please elaborate the hypothesis part of this question?
Yes. Pool. How many type of pool?
Two types of.
So how many parameters?
Two parameters.
Two parameters. So mu of A is same as mu of B. Okay?
Yes, now got it.
Next, second hypothesis. Come on, tell me. Mu of L,
H or M.
mu of M, and mu of H. Is the first one. Is the second one. So the problem definitely makes you identify, is it the data coming from only one source of variation or it comes from another source of variation? In one-way ANOVA technique when I started, I have to type the data correctly. But if I read the data, typing time is saved. But hypothesis is either for row-wise or column-wise or both. A or B is the function, no matter one-way ANOVA or two-way ANOVA. Let us see the question paper once again. That is what my module 6. Any question? Any question? Anybody?
Sir, just
Yes.
a doubt. Sir, you ran model 2 and model 3. Can you just show model 2 once?
something wrong happened. Just wait. Okay. I'm waiting for the program to respond. Just wait. Okay, I will show you, but meantime you can ask the questions of difference between ANOVAs. Anyone?
Sir,
How do you distinguish between one-way ANOVA, two-way ANOVA?
Sir, when I ran the test, I got different values because I only ran. So basically, I did BRX, then that tilde sign, and then I did based on wool and tension. The
wool plus tension.
Yes, wool plus tension, sir. The acceptance and rejection criteria, I mean, I still matches, but the values that I got and the values that
value
you
will be different. Value will be different. That's what I told you, the example of equation. That is what I told you about an example of an equation.
Sir? Sir?
I think his laptop is malfunctioning.
Did he leave the meeting?
No, he's here. It shows recording. So sir is in the meeting. Sir, you're on mute.
Excuse me, sir. Sir, you're on mute.
Yes. See the model 2. Somebody asked me. Everywhere variable is 1. That is breaking strength. But the breaking strength average, you are comparing between wool, you are comparing between tensile strength all together.
Sir, would these be the right conclusion? Sir, that the mean breaking point because of wool is similar and the mean
there is no significant difference in average breaking strength between type A and type B wool.
Okay, and the second one, that the mean breaking point, breaking strength
Under the levels low, medium and high are
different,
significantly
different. Okay, thank you, sir.
Anybody else?
So here, how are you taking the mean breaking strength as the dependent variable?
Yes. Main variable is breaking strength. Type of wool is a string. Tension level is also string.
What if the other two variables are not string? Then how do we come to know about the dependent and the independent variable?
Variable is always one in any of the testing. Measurable characteristic breaking strength, but it is coming through different type of wool and different type of levels of tension. Clear? Like workers. Workers are different. They are independently working on the shift. So the values are worker and the shift. Joint effect of worker and the shift. Correct, na?
Yes, sir.
So one observation is coming from two different sources. String 1 worker, string 2 shift. Same way, wool are of two type A and B, tension strength also different. So each observation is depending on type of wool and the level. That is what happened.
So, sir, for ANOVA, we just work on string variables, like on string value.
Average on measurable characteristic compared with string variable. What is mu A?
Type of wool.
No, mu A.
The mean of type of A.
Type of wool.
Mean breaking strength of wool A.
Yes, sir.
What is mu B?
Mean breaking strength for wool B.
Bas. Come on. Mu L.
Mean tension, what do you say? Low tension. Wool A.
Mean
For wool.
breaking strength under.
Tension, low tension for wool.
Mean breaking strength under. Next. Medium.
Medium strength.
And mean breaking strength under.
High strength.
In both the case, what is mu stand for?
Mean
breaking strength.
Mean of what?
Breaking strength.
Of the wool strength.
Correct, na? So you are comparing the average performance of the variable among group. ANOVA. Okay, any other question? So, this is what testing of hypothesis on mu.
So one variable which is breaking strength has been distributed into two different groups. That is, first is type and then the tension strength.
Two independent group.
Yeah. Got it.
So, sir, we could say that in two-way ANOVA, we measure we make the comparison between the mean of three or more group of data where two independent variables are considered. Like here, tension and low tension, high tension, and yes, and the second one is that the strength.
Yeah.
Okay.
See, all of you see the confusion I have written at the end. This is what test of hypothesis on mu. Either 1 mu, 2 mu's, or more than 1. We so far did therefore testing of hypothesis on parameter mu. Testing of hypothesis on parameter mu. In one parameter mu, critical value approach, p-value approach using standard normal distribution. In two parameter approach, critical value approach, probability value approach, and two mu's. More than two or more than one, directly you can go for ANOVA, p-value approach. Let us see the question paper once again. Somebody should explain me what is the nature of this data. All of you read carefully. Is it a measurable characteristic or countable characteristic?
So it's countable. It's basically preference of people for particular type of soft drink.
Correct. Is there a meaning of average here?
So in this case, no.
Can we find average of 762 plus 484 divided by 2?
Yes, sir.
Why yes? Can you add male plus female divided by 2?
No, sir. So we can.
This were the 10.
Only total you can get, isn't it?
Yes, sir.
What is the probability that a customer comes male?
Sir.
1557 divided by sum of 1557 and 1200.
Perfect. What is the probability that a customer prefer lemon juice?
It's a 945 by 2757.
What is the probability that a customer is male and prefer tea?
That's 762 by 2757.
Given that the customer is male, what is the probability he will prefer coffee?
327 divided by 1557.
देख लो. How many probabilities are associated to the characteristic gender and soft drink? Many, isn't it?
Yes, sir.
among this data, which number is high?
Male's
Sir, male and preference for tea.
Correct. For which it is low?
Female coffee.
Correct. So the probability a male prefer tea is much higher than that a female prefer coffee, and others are in between. Correct, na?
Yes, sir.
Yes, sir.
All of you agree?
Yes, sir.
Oh. And that number is based on this sample 2757.
Yes, sir.
Suppose if I increase this to 5000, will the probability remain same? I don't know. Correct, na?
Yes, sir.
Therefore, if there is a variation from sample, probability for each of the combination of cells equal or different, I cannot apply ANOVA. We have to apply another procedure called chi-square model. Because the chi-square data is a count data, correct, na? The chi-square data is a count data. Let us see another one. Okay. Listen. Advertisement. Yes. No. And the gender is male, and 34 saw the advertisement and 43 not saw the advertisement. Female. (28) and 23. It is a survey, attentive, of preferring surf detergent. "34 male customers said, we buy it after seeing the advertisement. 43 of other male group said, we buy, but we have not seen the advertisement. At the same time, females. 28 don't say, we buy the surf, but saw the advertisement. 23 of other group says, we have not seen the advertisement, but buy. Wants to know whether there is an advertisement effect on purchase of the brand. Do you follow the survey?
Yes, sir.
So here arithmetic mean is not possible. We have to use chi-square test. So where chi-square test will be used? chi-square test will be used when the data is a count data from string variables, categories, non-numeric, and so on. That is what we are going to do on Thursday. If the variable is measurable, we can apply ANOVA technique. We can apply one-way ANOVA, two-way ANOVA. We can apply t-test and so on. If the data is not measurable, then we can go by chi-square test. That is what we have to do in the next class. And in the next class, all these chi-squares are based on binomial approach. So, everyone should revise the binomial approach, prepare and come. Yes. Any question to anybody? If I do chi-square, it will be too heavy for you. So better that chi-square we do on Thursday. Till ANOVA, I have used only arithmetic mean as the parameter. And that is used for measurable data. That is used for measurable characteristic. But the last data that I have shown is for countable data. So any question now? Today, Rahul Giri asked me plenty questions on regression. That is the work I have to do after chi-square test. So there we are repeating correlation regression. There we are repeating correlation and regression. So slowly you are coming to recall correlation coefficient, regression coefficient, R square, and so on once again. So chi-square test at present I will not be doing for you. Okay. Anybody want to ask anything?
Sir, can you please explain again, like when to use one-way ANOVA and when do you have to use two-way ANOVA?
Yes. Whenever you want the average comparison of one string variable, one-way ANOVA. Like workers and assembly type. But if I want to include one more shift wise, Then the same data, there are two characteristics. Workers are different, shifts are different. So perform two-way ANOVA. Shubham Jain.
Yes, sir.
Clear?
Yes, sir.
That is what we did in warp break coolant. Anybody else?
Sir, I didn't understand the chi-square distribution.
Which one? Chi-square distribution. Chi-square distribution I didn't take in detail today. I said only the data difference. In the data which I have showed is men and women, tea, coffee and lemon juice, observations are not measurable. It is countable. Their arithmetic mean test not possible. Their arithmetic mean test is not possible. So wherever the data is countable, instead of mean test, we do probability test. Because you learn in probability numerator upon denominator. How? That is what the detailed learning of chi-square in third class. That is Thursday. Okay, any other question?
Sir, I have emailed you the files of Savvy and
Yeah, I will check. Rahul Ghosh.
Yes, sir.
Do you follow today's class?
Yes, sir.
Explain.
So, we did today
Yes. Basically, it's a statistical method which is used to test differences between two or more parameters. Its full form is analysis of variance. Then we did one example of one-way ANOVA where there were workers and assembly time. And then we did two-way ANOVA test where there were workers plus shifts. Then
yes. So you will be able to distinguish between one-way ANOVA, two-way ANOVA?
Yes, sir.
Good.
Thank you, sir.
Sujit Kumar.
Yes, sir.
What is the meaning of count data?
So the data that can be counted as it cannot be measured. For the count data, we apply chi-square test.
No, I am asking the difference. Count data. Give an example and explain. Yes. Okay. Anuj Srivastava. Anuj. Okay.
Sir, I have a question.
Yes.
So can we use any other? Can we generate any? Can we use any other data from file to perform the ANOVA test?
Open it and check. You can go for data parenthesis, open, so you will get list of file. Open one and check. Unless you check it, you cannot distinguish between ANOVA. Is it okay?
Yes, sir.
Yes, anybody else? Okay. So slowly you are aware about the test of hypothesis and conclusion making. Everywhere there is an H0. Everywhere there is an H1. Everywhere there is an H0 and there is an H1. Accept or reject H0. Test of hypothesis. But method of procedure different. That depends on data. That is what the conclusion. That is what the conclusion. Mihir Sakrika.
Yes, sir.
Have you copied today's coding?
Yes, sir, I copied. You took it purposefully slowly. That is why I copied, sir.
Anjali Garg. Anjali Garg.
Sir, she has some connectivity issue, sir.
Okay. Priyanka Bokil.
Sir, present, sir.
Yeah. Is it clear?
Yes, sir.
So can you explain me in short? Test of hypothesis.
Sir, in terms of ANOVA or only test of
In
hypothesis?
general, test of hypothesis.
Sir, when we are trying to, when we have made a claim about the parameter of a given data and we want to test it, whether it is right or wrong based on the sample that we have selected.
Okay.
That is what it is.
Okay. Rashi Jain.
Yes, sir.
Is it clear? The test of hypothesis?
Yes, sir.
Okay. So today I will be stopping, and Thursday we are going to work on chi-square in detail. Everybody should come prepared with binomial probability. Goodbye. Have a good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.